Since 8 o'clock this morning. We left off last time, we were talking about solving equations, and we looked at some relatively complex equations. Let's just kind of step up through the middle to the more difficult ones. The biggest type of equation you're going to need to be able to solve are ones that look like this. So here we've got 5x minus 7 equals 33. Oops, thank you. So this is a two-step equation, and what that means is there have been two things that have been done to our variable to build this. And we discussed that on Wednesday. What's been done to the variable here? Well, order of operations says that we multiply before we add, or before we subtract. So x in this case, the variable would have been multiplied by 5, and then the 7 would have been subtracted from it. So when we take this apart, we reverse that process, as we've mentioned. First thing we get rid of is that last piece that was put on. So we add the 7. So 5x equals 40. From there, we have to divide by 5 to get rid of multiplying by 5. X equals 8. And we talked about putting that number back in where the variable was and checking to make sure we get the same value on both sides. At this point, I'm going to assume you guys can do that double check if you want to. Like I said, this is the most important form of an equation that we can solve, is this two-step form, because most of the equations that we're going to look at, it's just a matter of doing some simplification and combining to get them to that form. And that's really the form we're going to solve, even if they look way more complicated. Now, we saw equations with parentheses in them, like this one. 3 times 6x plus 4 equals 58. And in an equation like that, we see the parentheses, which always should draw us to do something there first. And we have the two questions. The first question, is there anything to do inside this parentheses? Is there anything I can do inside here? No. So in the second question, is there anything that needs to be done to this set of parentheses? Is there anything that needs to be done to the parentheses here? Yeah, what is it? Times 3, very good. So 3 times 6x is 3 times 6 is 18, so 18x, good. 3 times the 4 is 12. So 18x plus 12 equals 58. And as you can see, we are now in that two-step form. So what's our next step to solve this? Our first step to actually to solve this? Subtract 12. So 18x equals 58 minus 12 is 46. And final step? Perfect. We divide by 18. So the 18 is gone. X equals 46 divided by 18 is not going to come out perfect. If we divided it out, it would actually come out to be 2.5555 repeating. So we can either take that and round it. If we're not given a decimal place to round it to, a typical rule is you go 1 decimal place past the given information. Now in this case, all we were given was the equation, but none of the numbers in the equation have any decimal places in them. So that would mean is we round our answer to 1 decimal place. If the numbers in our equation had 1 decimal place in them, we would round our answer to 2 decimal places, and so on. So we could list that as 2 point, what would that round to? Rounding it here, the next digit's a 5, so that tells us that would round up to 6, so 2.6. Another option, if we wanted to give an exact answer as a fraction, 46 over 18, we can treat that division like it is just a fraction. We can go back and forth between those two modes. Both 46 and 18 can be reduced by 2, which gives me 23 over 9. And then I can turn that into a mixed number. 9 goes into 23 twice. 2 times 9 is 18. So that leaves us with 5 left over. So 2 and 5 ninths. So either one of those answers would be acceptable. We also saw equations where the variable appeared more than once. We might have an equation like this. (9x plus 5 plus 2x equals 82). So there, we find our equal sign, and we go to identify where our variable is, and we see the x appears twice, but both on the left side. So what are we going to do? We can perfect. Because they're on the same side, we can combine 9x and 2x, and that's going to give us what? 11x, and we still have the plus 5, equals 82. So now then, we're in that two-step form. What are we going to do next? Subtract 5. Good. 11x equals 77. And then divide by 11. So x equals 7 divided by 11 is, or 77 divided by 11 is 7. Now, if this were a quiz, and if I weren't sure about that answer, like we said before, go back and double check those answers. If x equals 7, that means I could put 7 in each of these spots for x, and I should get the same value on each side. So 9x would become 9 times 7, plus 5 plus 2x would become 2 times 7. That equals 82. Now there's nothing to do over here on the right side. That's just 82. So let's do our order of operations on the left side. 9 times 7 is 63. Then we can combine the 2 times 7 is 14. Now it's just addition, so we're going to add left to right. 63 plus 5 is 68. Plus 14 is 82. So we get the same value on both sides. Slightly different than that might be an equation that looks like this. So again, we find our equal sign, and we identify where our variables are. And the variable here, x, appears twice again. What's different about this one from the last equation?
X is on both sides of the equal sign.
Perfect. There's an x on each side. So they're not both on the same side, so we can't just combine them. So we have to get rid of one of them here. We still can't start to solve this until we've condensed the variable into a single appearance. What are we going to have to do here? Well, before we can start to solve, though, we have to condense those x's so it only appears once. We can't just combine them because they're not on the same side. Not divide, but subtract. Subtract. There you go. And how do I know which one to subtract? Usually the smaller one. It doesn't. We could subtract either one, but by subtracting the smaller one, it helps us to avoid working with negatives. So I'm going to subtract the 8x. Make that go away. That's gone. What am I left with on the right side over here? It's a negative 7. That minus 7 is going to become a negative 7. But I still have to subtract 8x from the other side. I take it from the 14x. It'll leave me with 6x negative 13. 6x minus 13. Good. Now the variable only appears once, and we are able to start to solve. So what are we going to do with it? Very careful there. Not subtract, but add. It's minus 13, so we have to add 13. So that's gone there. We got 6x here. What is negative 7 plus 13? It's a positive 6. Then what? Divide by 6 to get x equals 1. And again, if this were a quiz and you weren't sure about it, I would go back and replace x with 1. So this is 14 times x. 14x becomes 14 times 1 minus 13. 8x becomes 8 times 1 minus 7. So on the left side, 14 times 1 is 14. Minus 13 is 1. On the right side, 8 times 1 is 8. Minus 7 is 1. So 1 does equal 1. So I know that that answer is most likely the correct value for x. We'll look at some that are more difficult to simplify in a little bit. But we can move up the ladder and we can run into equations that look like this. You know, I'd said a few minutes ago that most of the equations we run into fall into that two-step form. Well, here's one of the few exceptions to that. This equation right here, that we're down to the variable only appearing once, but this is not in that two-step form. There are 3 things that have been done to the variable. We have 2 options to solve this. One of those options is to divide it out. What do I mean by that? Well, I can treat this here like distributing. I can distribute multiplication, but I can also distribute division. If you remember when we did polynomials, like we had 12x squared minus 15x divided by 3x, I could divide each piece. 12 divided by 3 is 4, x squared divided by x is x. Negative 15 divided by 3 is negative 5, and the x's divide out. I could do a similar thing here. 3x divided by 4 is going to be 3/4 x. Positive 7 divided by 4 is going to be a positive 7/4. Well, that forces us to work with fractions, and I want to kind of avoid that for a few more minutes now. The other option, the simpler option, is to just add a third step, put a third step into solving this. If I'm looking at my order of operations here, what's been done to my variable, what's been done to x, the fraction bar says I have to do everything on top first. So x was multiplied by 3, then the 7 was added to it, and then finally, once everything on top of the fraction bar is done, then we can divide by the 4. So we divided by 4. To solve it, we take off the last piece first. It was divided by 4, so we're going to multiply by 4. Multiplying by 4 makes that go away. We're left with 3x plus 7. We have to do 7 times 4 is 28. So by multiplying by 4, all I did was take off this piece here. And now we're back to that form that we know how to solve. What are we going to do next? Subtract 7, good. 3x equals 21. And then divide by 3. So x equals 7. And as always, I'm not going to do it this time, but as always, we could plug that 7 back in for x in the original equation here and verify to see that it does come out to the same value on both sides. Well, outside of that two-step form where we have either addition and subtraction and then dividing to get rid of multiplication, we do have other operations we run into. This is a power here. X to the third power. What's the opposite of a third power? A root. It's a cubed root. Very good. The index of the root, which is this number here, has to match the power of the variable. Remember, the third root is asking us what number to the third power equals this. So the third root and the third power cancel out. That gives me x. What is the third root of 27?
3.
3. Perfect. 3 to the third power equals 27. If I give you that y squared equals 64, what's the opposite of squaring? That is the square root. So now the square root of y squared, the root and the squared just cancel out to give me y. What's the square root of 64? 8. And there is one other possibility. Negative 8. Remember, when it's a square root, in fact, in any even root, there's always two answers. For our purposes, we're generally just concerned with the positive result, but we need to be aware that that negative result is there because there are a few rare cases in practical application where that negative result is the one that applies to the problem. We did look at, we could add steps then with that root, that power. Now let's look at one like this first. If the square root of x equals 7, how do I get rid of that square root? If I got rid of squared by using a square root, I get rid of the square root by squaring it. Very good. So the square root and the squared cancel out, leaving me with x. 7 squared is 49. Wonderful. We can have one like this. Now, again, you look at what's been done to our variable. This time the variable is y. So we ask, what's been done to the y? Well, if y were a number, according to order of operations, the first thing we would have to do here is the exponent, the square root. What's the next thing that we would have to do? Once you did the root, you would multiply by the 3. And the last thing that would be done would be adding the 4. So this equation was built by taking our variable, square rooting it, then multiplying it by 3, and then adding 4 to that result. So when we go to take it apart, we have to take off the last piece first again. Adding 4 was the last thing that was done to build the equation. So it's the first thing going to be that we're going to do to take it apart. Subtract 4. That takes that piece right there off. So 13 minus 4 is 9. The left side is just the 3 times the square root of y. Then what do we have to do? Exactly. Divide by 3 is the next thing we got to do. We're getting rid of the multiplying by 3. So 9 divided by 3 is 3. The 3's here cancel out, and we're left with the square root of y. And finally,
You have to cube the...
not cube it,
Square it.
square it. There you go. Good job. The square root and the squared cancel out, leaving me with y. 3 squared? 9. Wonderful. We can run into questions like this. This is exactly like having one that is 5x minus 2 equals 38. Let's do these equations side by side so you can see how they're the same. Over here on the right side, what would we do first to solve this? You would add 2. On the left side over here, the equivalent would be doing what to start solving this one?
Adding 5 1/4.
Adding the 5 1/4. So the process is exactly the same, it's just there's fractions involved. So we have the 3/8 left over, 3/8 x left over here. Now at this point, I'm going to do this in my head for us. 6 1/2 plus 5 1/4 is 11 3/4. I'm going to trust at this point you guys can add fractions, or you can use your calculator to add them if you need to. Over here on the right, what's our next step?
Divide by 5.
Divide by 5. So we get x equals 8 over there. On the left side, what's the equivalent step? Divide by 3/8. So we're left with x here. Now we have to do the 11 3/4 divided by 3/8. We have to make that into an improper fraction. 11 3/4 becomes what is an improper fraction? Eleven times 4 is 44, plus 3 is 47. And instead of dividing by 3/8, we're going to multiply by 8/3. Good. And since this is multiplication, we can cross cancel like any other multiplication. 4 and 8 both divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So we multiply 47 times 2 is 94. 1 times 3 is 3. Now we have to make that into a mixed number. 3 goes into 9 3 times. There's nothing left over. Bring down the 4. 3 goes into 4 once, with 1 left over, so that's 31 1/3. So x is 31 1/3. So you can see the process here was exactly the same as with the equations we've been doing. This is just a two-step equation. We have to add or subtract something, and then we have to divide. The only difference is the fractions make it look uglier. Similar to that, we can run into something like this. So again, this looks uglier because it has the decimals in it, but this is no different than having 2x plus 3 equals 11. Over here on the right side, what would I do first to try to solve this equation?
Subtract 3.
I would subtract 3. So 2x equals 8. On the left side over here, what would that first step be?
Subtract 2.7.
I would subtract the 2.7. So 8.1 minus 2.7 is 5.4. Back over here on the right side, what would be my last step?
Divide by 2.
I would divide by 2. So x equals 4. On the left side here, what would be the next step?
Divide by 1.4.
Divide by 1.4. So now x equals 5.4 divided by 1.4 is going to be 3.85714,286 approximately. Now here's the question. See if you remember back. Where should I round this off? Well, here the numbers in the equation have 1 decimal place in them. So we said you go 1 decimal place past the numbers given. So if these have 1 decimal place, our answer should be rounded to 2 decimal places. So we'd round that to 3.86. Any questions? Okay, well, let's keep going. we can run into an equation like this. An equation like this, we have two options. I think the first one is the easier option, and that is when you look at x over 3, that is the same thing as saying 1/3 times x. So if I look at it that way, x over 3 is 1/3 times x. Oops. Plus x over 7 is 1/7 times x equals 20. Now if I have 2x plus 5x equals 35, what would be my first step to solving this equation? I would have to combine the 2x and the 5x to get 7x, wouldn't I? 7x equals 35. Well, it looks very different over here, but my first step is exactly the same. I'm adding 1/3 x and 1/7 x. To add 1/3 and 1/7, 1/3 plus 1/7 is 10/21 x. Now again, I realize I didn't do that out longhand, but I'm going to trust at this point you guys can find the common denominators and add the fractions, or use the calculators to add them. So 10/21 x equals 20. Now that I've combined those, I can go ahead and solve the equation. What's my only step that I have to do to solve this equation? Division. Perfect. We're going to divide by the 10/21. So the 10/21 cancels out. I have x here. 20 divided by 10/21 is 42. Well, let's combine some things like 3/4 x minus 1/2 over 3/8 equals 2 1/4. So when I look at something like this, guys, this is exactly like one I did earlier, only there's fractions in it. Remember, we had that one that was 2x minus 3 over 4 equals 7, something like that. The first thing we had to do is we had to get rid of this number under the fraction bar. So I'm going to do the same thing here. So what's going to be the first thing I do here to solve this equation? I have to get rid of the 3/8. How am I going to get rid of the 3/8? This whole side of the equation is divided by 3/8. I get rid of it by multiplying by 3/8. That's gone. I have to multiply this side by 3/8 as well. So on the left side here, this is gone. I still have the 3/4 x minus 1/2. On the right side, I have 2 1/4, which is 2 times 4 is 8, plus 1 is 9/4, times 3/8. 9 times 3 is 27. 4 times 8 is 32. So that's 27 over 32. What's my next step? Add 1/2. Very good. So 3/4 x here. Over here, I'm going to write this instead of 1/2. I'm going to write it as 16/32. 1 and 16/32. 16 over 32 is just 1/2. 27 and 16 add to make 43/32. So that's 1 and 11/32. So I am going to carry the 1, and I'm going to keep the 11/32. 1 and 1 makes 2. So I have 3/4 x equals 2 and 11/32. What's my final step?
Divide by 3/4.
Divide by 3/4. That leaves me with x here. I have to divide by 3/4 over here. So I have to make this improper. 2 times 32 is 64. Plus 11 is 75 over 32. Dividing by 3/4, I'm going to multiply by 4/3. Now, before I start multiplying here, what can I do? I can cross cancel. 75 and 3 both divide by 3. 3 divided by 3 is 1. 75 divided by 3 is 25. Is there anything else I can cross cancel? Yeah, 4 and 32 both divide by 4. 4 divided by 4 is 1. 32 divided by 4 is 8. So we've got 25 times 1 is 25. 8 times 1 is 8. 25 eighths. 8 goes into 25 3 times with 1 left over. So it's 3 and 1/8. We could also run into this. So looking at something like this, where am I going to have to start?
Multiply 1.8.
Exactly, I have to multiply by the 1.8. So that makes that go away. I have to multiply by 1.8 over here. So on the left, I have 2.1x minus 1.2 equals 7.2 times 1.8 is 12.96. Then what?
Subtract 1.2.
Subtract 1, or not subtract, but add 1.2. So 2.1x equals 14.16. And then divide by 2.1. So x is going to equal
6.74.
perfect. 6.74 times 6.74 is that 2.8? Yeah, 2.8. Like that. And yes, you are absolutely correct. We have one decimal place in our problem that was given. So we have to round our answer to 2 decimal places. So 6.74 is exactly where we want that rounded off. Good job. Any questions? Okay, we can also throw into the mix things like this. Oh, let's see. So looking at this, what do we have to do?
Take the 3/4 and multiply by the numbers in parentheses.
Exactly. We have to multiply the parentheses times the 3/4, the 3/4. So 3/4 times 1 1/3. That's going to be 4/3 times 3/4, which ends up being just 1. So that's just 3/4 times 1 1/3 x is just x. Now we have to do 3/4 times 4/9. 3/4 times 4/9 is, the 4's cancel out, the 3 and 9 cancel out to give me 1 and 3. That's just 1/3. So what we have so far is x minus 1/3 equals 2.5. Now what?
Add 1/3.
We just add 1/3. That's it. X equals 2.5 plus 1/3. Well, that's going to be 2 and 3/6 plus 2/6 is 2 and 5/6. I'll give you one that doesn't work out quite so nicely. So this one here doesn't work out quite as neatly as that last one did. We have to multiply by the 2/3 again. So what is 2/3 times 2 1/4? We have to make 2 1/4 into an improper fraction. That'll be 9/4. So it ends up being 3 halves, or 1 1/2. So it's 1 1/2 x. We have 2/3 times 1 3/8. 1 3/8 has to become an improper fraction. That'll be 11/8. We can cross cancel the 2 and 8. We've got 11 over 12. So that's 1 1/2 x plus 11/12 equals 3 3/4. What's our next step? Perfect. We subtract 11/12. Leaves us with 1 1/2 x over here. Subtracting 11/12 over here will make this 3 and 3/4 is 9/12. We're going to have to borrow. So this will be 2. And how many 12ths does this become? When we borrow with fractions, what we borrow is the denominator. So 9 plus 12 is 21/12. So now we have 21 minus 11 is 10/12. Well, that reduces to 5/6. And then 2 minus nothing is just 2. So 1 1/2 x is 2 and 5/6. And our final step? Divide by 1 1/2. So x equals 2 and 5/6 divided by 1 1/2. Again, improper fraction. 2 times 6 is 12, plus 5 is 17/6. 1 times 2 is 2, plus 1 is 3 halves. This stays 17/6. This is going to be times 2 over 3. Reduce the 2 and the 6. Give me 1 and 3. So that's 17 over 9, which is 1 and 8/9. Not so bad? Not horrible, right? Okay, so one example left. So here, what do we have to do? I heard somebody say it already. We have to multiply by the 2.5. Good. 3.4 times 3.4x times 2.5 is 8.5x. Wonderful. 2.5 times negative 2.8 is a negative 7. Good. Now what's our next step? Add 7. So 8.5x equals 7.1 plus 7 is 14.1. And our final step? Divide by 8.5. So x equals 1 point what?
1.658823529.
Okay, so we can stop there. Our data, our numbers in our problem are given to 1 decimal place. So where do we have to round our answer off at? 2 decimal places. So 1.66 is where we would round that. Any questions? Okay, well, it is that time. It's 2:45 here. So I will let you guys get started on your quiz. Read them carefully, and like I said before, when you get an answer, make sure you put those numbers back into the formula and check to make sure you get the same value on each side of the equal sign. Last class, I gave you guys a bunch of pages out of the book to do for homework. So I'm not going to give you any new homework today because I figure you're probably not done with those yet. But yes, I will give you, let you go ahead and take our last 15 minutes here to start on the quiz.
All right. Thank you, sir.
You bet. Thank you.
All right, gang.